Hello, I am a Bullis Student Tutor. In this video, we will be introducing probability. Probability deals with the likeliness of something happening. Probability questions sound a little like this. What are the chances? How probable is it that? What % chance do I have if? How likely is it that? What is the probability of? In all those questions, you're taking the possibility of something happening. Right now, I want to try to conceptualize what probability is. Probability will often be seen in fractions or percents, and we remember the formula for percent is equal to part over whole. And again, probability is asking for the likeliness of something happening. So we're going to have to look at all the possible things that might happen, and we're going to have to compare that to what we want to happen. To do so, let's look at our coin. Our coin has two sides, tails and heads. We are trying to find the probability of it landing on heads. To do so, like I said before, we need to look at the total option of things that might happen. Being it has two sides, heads or tails, we can only get two results. It's either going to be heads or tails. So the total amount of results, or the whole the coin can be, is going to be 2. And that's going to be part of our percent. What we want to happen is it lands on heads. Heads is one of the two options. So the part we want it to land on is heads. So that's one of the two options. What we now have is the fraction 1/2, which is equal to 0.5, which is equal to 50%. What we just learned here is that 50% of the coin is heads. So, assuming that it won't land perfectly straight up like it has here, we know that there is a 50% probability or 50% chance of it landing on heads. Why, real quickly again? You have two sides, we want one of those sides, so only 50% is what we want, and there's another 50% that is what we don't want. So we have a 50% chance of getting what we want. We're still trying to conceptually understand it, so now we're going to add a few more players to the game. So we have a box of 6 emojis. 2 sad emojis, 2 happy emojis, and 2 angry emojis. What are the chances of us getting a happy emoji? We see right here that in total, the whole amount of emojis we have is 1 sad, 2 sad, 3 happy, 4 happy, 5 angry, 6 angry. So we have 6 total emojis, but we don't want a sad emoji, and we don't want an angry emoji. So that leaves us with 2 happy emojis. So the chances of us getting a happy emoji is going to be 2/6. We have a 2/6 chance of getting a happy emoji because there's 6 total emojis, but we only want 2 of them. That in a fraction is equal to 0.33, which is also equal to 33%. So again, what this is saying is 33% of the emojis in this bag are going to be happy emojis. 33% of emojis in this bag are going to be the emojis we want. But 67% of the emojis in this bag are not what we want. 33% make up sad emojis, and another 33 make up angry emojis, which is not what we want. So the chances of us getting a happy emoji are 33. And we got that because the whole number of emojis is 6, and the part of emojis that we want is 2. We want 2 out of the 6, and we know percent is part over whole, so we put that 2 as part over the 6 as whole, and we got 0.33, which we know we can get to a 33% percentage. A probability problem would look and sound like this. My son has 4 blue polo shirts and 1 white polo shirt. If he randomly grabs a polo shirt from his closet, what is the probability he grabs a blue one? So right away, we see that he has 4 blue polo shirts. And he has 1 white polo shirt. And we are looking for the probability that he will grab a blue polo shirt. So in total, like we did before, we see that percent equals part over whole. And the total amount or whole amount of shirts that we can choose from is 5, because we can either choose 4 blue polo shirts or 1 white polo shirt. In total, there are 5 possible shirts we could choose from. The amount of shirts we want, or the part of shirts we want, are those 4 blue polo shirts. So out of the 5, we only want 4. And that in a decimal would be 0.8, which is equal to 80%. So in that closet, 80% of the shirts that are in there are what we want. We have an 80% chance of pulling a shirt that we want out of that closet. Why? Because there are 4 blue shirts, which are the ones we want, out of the 5 total. There's a 20% chance we pull a white shirt, which we don't want. So one more time, probability is a measure of the possibility of something happening. It's a comparison between the total amount of options and possibilities of an outcome compared to the amount of what we want to happen. So the higher the probability, the greater chances of that happening. And for our problem here, we had a high probability of 80%, and we have a great chance of choosing a blue shirt because there is only a 20% chance of us choosing a white one. I used to make omelets with 4 eggs, but the FDA said that 1 in 4 eggs may contain salmonella, so now I make omelets with 3 eggs. I hope you understood that little joke. If you did, you understand probability and you are ready to go in the world of odds and chances. This has been a Bullis Student Tutors video. If you enjoyed this video, please be sure to check out the rest of the videos on our page. Thanks for watching!